Hi, my name is Rick. I'm with Jaycox store in Laverne, Minnesota. Today we're going to go through some maintenance preseason things on a Case IH 1255 corn planter. To begin with, we'll probably run through some meter things as far as identifying wear and problem spots. With me today, I also have Turner Hagen here. We'll see whether or not we can tag team that. To begin with, typical meter on a 1255 planter. This happens to be a soybean plate, which we'll cover in a little bit. When we pull the meters off of our planters, we need to look at some basic things. We want to rotate the bearing by hand. It should turn freely. It should run smooth. It shouldn't have any dryness or anything that feels catchy, that we got a rough bearing. We want them to run as smooth as possible. This component is just an agitator. If you think your agitators are worn quite a bit, stop by, grab a new one, and compare. The fingers on the agitators we want full length. We don't want them wearing significantly shorter. The Singulator here is this component. Typically when we're planting corn, that dial will set on number 3. When we go to soybeans, we'll set it on number 8. Those are typical out-of-the-box settings for corn and soybeans. The dial is right here under the mini hopper on the same side as the meter cover where the seed plate goes. You can see, you can just turn it by your finger, and hopefully you can see where the 3 spools change their locations as we turn the dial. This meter happens to look very good. It doesn't seem to have a lot of wear on these little spools. You should be able to easily rotate them with a finger. They should turn freely. If they're stuck, we may have to pop the little snap ring and pull them off and clean them. A little bit of graphite in them is just fine. That's normally a little lubrication we can use. The little groove in the outer diameter of these spools is largely a wear indicator. If you see those worn down to where it's getting into where that groove is, we should be replacing those and getting new ones on there. Replacement too, if you feel around them or if you can identify flat spots, any unusual wear that they're not truly round anymore, we should just be putting in new ones. On the other side of the meter, we've got a seed gate. With the cover on, we can see the location. The seed gate changes the opening where the seed comes into the meter. We can go from full shut, which would be position 0, open one step to position 1, open the second step to position 2. That's typically where we're going to run our planters for Southwest Minnesota, corn and soybeans. The bristle brushes around the outside of the meter here, largely that is simply to seal the meter. When the plate is in, the plate simply lies on that brush, and the plate turns over that, and that's really the only purpose of that brush, is just to seal up the meter and make sure it doesn't leak any seed. For maintenance purposes, we can just use a blowgun, maybe a screwdriver or something to rough them up, blow the dirt out of them so that they're soft again. And as long as there's no openings or any major voids in the brushes, they'll be just fine. This happens to be a cable drive meter. This is simply the gearbox where the cable attaches. If for any reason we want to shut one meter off and have it not plant, this mechanism right here can be used for that. We unscrew the nut, push it around, and screw it back in to lock it. that will physically disengage the drive on the drive port on the gearbox. For the planters with electric clutches, air clutches, things like that, we can actually do that function from the display. Cable drive gearboxes are sealed units. There should not be any necessary maintenance required. They are supposed to be sealed. In an extremely rare situation where planters may sit outside for an extended period of time and be exposed to rainfall and other sources of moisture, we have experienced a little bit of corrosion, but it is very rare anymore today. For a chain drive planter, the only other maintenance would be to check the drive chain, the chain tensioners, sprockets, and then this mechanism here on a chain drive planter, we should have grabbed another meter, is simply a different component. We're just checking it for wear. When it comes to meter performance and singulation, we are looking very closely at seed plates. This plate happens to be a soybean plate. These are corn plates. This happens to be a 36 cell corn plate. This is a new one. This cell is a 48 cell on a 30-inch row planter. We're typically using either a 48 cell corn plate or a 36. There's specific reasons why we would change that. For the higher speed person that wants to maybe travel at least 6 miles an hour and plant in that 34 or 5,000 area, we're probably going to choose a 48 cell plate. Some of the older planters, that's really the only plate we ever used in the past because the 36 was not available. For the person that's maybe planning more closely to that 28 to 32,000 and 5 miles an hour is fast enough for you, the 36 cell plate is the much better option. It keeps our meter speeds in check and the meter running in its optimum speed range. When it comes to singulation specifically, I don't know if you can see this in the camera. When we compare a used plate versus a new one, the new plate around the hole is very flat. The hole is very precise. The used plates, the plate begins to be not so flat. On the downhill run on this side of the hole, it's begun to erode. There's actually a slight recess in the plate. As they wear farther, the hole will actually begin to elongate a little bit. And this right here, the wear in the plate on the seed carrying side, is specifically what has a huge effect on singulation. If in doubt, you're not sure what maybe you want to see, you could give any of us a call and we could talk through that situation. Or grab a couple of plates and swing by the store. We'd be happy to show you exactly what you've got and talk about the unique situation that we would forecast that your row unit would run. The flip side of that is if you really think you have meter problems, we do have a meter tester here at the store. It is a precision plant meter tester, and we can probably run meter tests at any time if anyone feels they need to. So one more thing comparing seed plates, again, this one being a brand new plate, this one being something that is now about 8 years old. This is the older material. That plate will feel a little bit stiffer. The new material for these plates is slightly softer, a bit more flexible. What we find with our meter tester is that with the new plates in, the new materials, these meters actually will turn about 10 inch-pounds easier. as far as measuring the torque on the meter while it's planting. The new material in the plate turns about 10 inch-pounds easier, and we get that from our meter tester. To add into that even just a little bit more, the new seed covers that snap on over the plate, the vacuum cover, is also a slightly different material. And where I was talking about them being flat and checking that, the new covers with the new material are also much more consistent. When it comes to meter covers, we want them to be very flat. A very simple straight edge would be just a nice straight piece of iron, basically the same length as your seed plate diameter. We're going to simply lay it on the cover and look to see if our wear surfaces are flat, that the cover is not warped. On this particular cover, I can see where over here to this surface, these three are flat. When I fall to the outside, I am actually a little low on the cover. It's not terrible, but it is present. Anything that would be obviously not flat, we're probably looking to replace. The other thing for maintenance, we want to make sure these latches are functional, that they actually latch down nicely, hold the plate tight, hold the cover tight to the row unit. There is a little bit of plastic flashing, a little wear material, because the plate runs on top of this, where the vacuum chamber runs. We actually have just a little bit of roughness here that can very easily be shaved off simply with a razor blade on both edges or anywhere around where the plate runs. Any roughness, anything unusual, we can shave with a razor blade. We don't have to be aggressive, we simply need to take the roughness off of it. So this is a mini hopper off a slightly older planter. This came off at 1250. It'd be essentially the same thing as all the way back onto the 1200 planters starting in 99. This is a chain drive meter. This would have a sprocket with two steel pins in that engage this plastic drive. Again, we're looking at that to make sure that it's a quality piece. It isn't severely worn. They've got a few, like a gear mechanism in them for self-alignment. If we ever want to take this meter and shut it off in the field so it doesn't plant, we can simply roll the two dogs together like that, and this will not drive. In order to re-enable it, you just spin them back open again. Versus the gearbox, which is very much a no maintenance. We're not worried about alignment issues or anything like that with a cable drive. This meter, being chain drive, would use an air clutch if it had it, or an electric operated clutch in the chain. This one, being a cable drive, has an electric clutch here on the cable. The wire is plugged in. Again, it's really supposed to be a no maintenance type clutch. You can check it very simply when it's unhooked from the meter like this. If we grab it and just turn it with your finger, it should spin relatively freely in one direction. When we try to go the other way, it should hold tight. If you can't spin it like this in either direction, that pretty much means the clutch has a problem and we need to be looking at it, because it won't work correctly. The mini hoppers in these, can you pop the lid open? The mini hoppers in these are very different. The newer version, starting in 2012, has a cover on the top with a large opening. Very easy to see if the meters are getting seed in full. The hose has a quick connect, quarter turn quick connect on it, as well. The only thing with that is in that hose, which is right here, there is an O-ring up in there, and you do need to make sure that stays. If in doubt, maybe have 1 or 2 spares with you in the field. You wouldn't be the first person to lose one of them O-rings. The newer mini hoppers like that, again, very much maintenance free. There's really not a whole lot to have to worry about. There is some improved flow characteristics with that on the little bit newer planters. The older version like this, the seed enters through this single port. There is really no other openings for you to get into and see. These are a little bit more prone to seed plugging in the tube. We do get some comments from people where the seed actually plugs the tube right on top of this port. If you have much trouble with that, there's a few things that we can do to help resolve it. Step 1 is we need to look at the inner diameter of that port. It needs to be nice and round and smooth. It should not have any unusual characteristics to the inside of that port. If there is any plastic molding, any bumps or grooves, ridges in there, we basically need to sand them out so that it's smooth. It should be a nice, round, consistent port. Both of these meters have the seed dumps. These are the same. That is also changed over time. The older version used to have a metal clip in it. This is a little bit newer. All the way on the new planters today, they've simply eliminated it. Found we didn't use it very often. When we look at the bottoms of these mini hoppers here, there's a triangle tab in the bottom on both of them. They're slightly different, but it serves the same purpose. When we set this back in the row unit, we set it in on the front hooks and drop it in. This triangle piece sets into a matching groove in the metal frame. We set that down and pull it back. It needs to set all the way to the rear and tight. That will self-center it and lock it in. It serves 2 purposes that way, to get that pulled back when you latch that down. For the chain drive meters where the sprocket is in here to drive this, that should maintain proper alignment from the sprocket to the meter, as well as maintaining proper alignment to the seed delivery down the seed chute. And that is true from the early planters all the way through the last 1255s. Now, as far as seed meters and seed delivery, planting accurately to the ground, what we're looking at here is the seed delivery tube that sits below the meter and has the seed sensor in it. What we're looking at is we want to make sure the interior of that is smooth and clean. What we find is with treated seeds, it's seemingly soybeans may be a little worse. Sometimes that treatment is wet, a little sticky, and that can leave a residue in my seed tubes. And what that will do is cause the seed to bounce more. It can cause delays. We see a lot more seed ricochet in the tubes as it's delivered to the ground. So simply just look and make sure the interiors are clean and smooth. So for row unit maintenance, pretty much for all of the 1200 and newer planters through the 1255s, 1245 series, our opener blades, this happens to be a new blade. When you pull a tape measure on it, measure straight across, brand new is going to be 14 inches. There is a difference between the front blade and the trailing blade. This one happens to be a trailing blade where the bevel on the is to the inside of the blade. Your lead blades, the bevel will be on the outside. That is done to try and minimize the seed furrow, minimize or make a little bit sharper bottom. The bearings in these blades are a bit different depending on the planter you may own and how old it is. This is a standard blade, the 3.5 millimeter blade with a standard bearing. Used on a lot of planters, basically from 1981 and newer. The heavy duty blades with the larger bearings, the 4.5 millimeter blade, came to us some 8 years ago or so. And if you can see on this planter how much different the bearing is, that is a little heavier blade with the bigger bearing. The bigger bearings will need a little bit longer bolt and then this big washer on it to help protect that bearing. The standard blades like this also have a dirt cap over them typically. The closing blades, the factory closing blades, are like this. Again, same blade they've been using for many years. It has now been changed on the 2000 series planter almost 4 years ago. These blades will measure 8 inches brand new. The question, when should we replace the closing blade? Basically, if they're down to 7.5 inches or you're seeing bearing issues. That typically coincides. When they get below 7.5 inches, they've run enough miles where the bearings typically begin to get loose as well. Shoe and a point. This is our seed shoe assembly. We've been using this for a long time, and this is a forming point. Many years ago they called it a firming point, but it does very little firming. It simply forms the bottom of the furrow to make a nice sharp bottom. They fit together like this in the row unit. They sit in the bottom right here. When we look at that row unit, these points should remain loose. They should be free floating. If you notice how the bottom of this point is rather round versus a new one, this wears off as the blades wear. It actually runs about a 1/16 of an inch shallower than the blades cut. Again, its purpose is to simply form the bottom of the furrow so we've got a nice sharp bottom. The seed shoe, its main purpose is to hold the furrow open. We do not put any unnecessary compaction on our seed furrow when we open it. The shoe is in there basically to hold that open. It's a clean place for the seed to fall into the bottom of the furrow before that furrow would happen to begin falling shut. When we look at this particular row unit, there's several wear things that are become obvious. When we check the closing blade, this one is right near 7.5 inches. So they're very close, or maybe should be replaced for optimum performance. Hand me the other scraper. Disc scrapers, again, this just happens to be a new assembly. The individual blades are also available separately in parts. You would not necessarily need to replace the whole arm. The arms have been modified over the years. If we happen to have an older planter, it may have a scraper on shaped like this. This would be a direct replacement for it that would mount up like that. It does have a little more arc in it. It has a little more blade clearance, gives us a little more adjustability. The other thing, this scraper is quite worn. If we notice how much the blade is out beyond the end of the arm or the first rivet, this one is worn back a lot. Very, very worn. And you can see how much narrower it has gotten. Normally that scraper will sit on the blade right there. It is very important not to set our scrapers tight. When it comes to the opener blade, the only thing that rotates that blade is its engagement with the soil. They're pinched together here on the bottom. The soil basically comes through and rubs on the outside of the blade. So our blade needs to move like that. If your opener blades are set up too tight, if your scrapers are set so tight that that blade is difficult to roll, put your fingers on it and push it, a thumb, it should roll like that. Each blade then should turn independently. One blade should not rotate the other. Like I showed you, the new opener blades are 14 inches. This one, again, when we measure that, is right at 13 and a half. This planter really should be rebladed. A real quick measurement tool for myself when I'm looking at row units. My fingers, if I can slide a finger in right here on this cast iron point, if my finger fits, the blades are time to replace. Your opener blades, when we do replace them, are shimmed. On the inside there's a simple flat washer. Right here is the pinch point on the blade. There should be a space between, normally never more than 1/8 of an inch. The shim washers under the bearings, there's on both sides, we try and keep those equal. You can use that as a gauge for the pinch point on the blade for that gap. If one washer fits, if the blades will hold it, you're probably really close to correct. When we pinch the blades on the bottom like the field will do, like the dirt will do, that pinch point then should close, and they will touch. We do not want them tight together. That just is an increased wear. You want to hand me the gauge tire? Well, wait a minute. Let's do this. Again, with wear, the forming point will wear off as the blades wear down. We take a 1/2 inch off the blade. That blade will cut 1/4 of an inch shallower, which will make the forming point run a bit deeper, which then the bottom wears off as that occurs. So normally if we're reblading a planter, we will get new forming points as well. When we look at this shoe on this planter, this side of the shoe, hand me the shoe, is also nice and straight and flat. The other side, which I don't know if you can see, but the other side, if I put my finger in there on it, you see how much of my finger is hidden? The other side of the shoe is worn up nearly 3/8 of an inch. What has happened there is the shoe is actually off center ever so slightly. It's more dirt engagement on the one side, and the bottom of it is worn off. The bottom edge here will actually wear off and be up higher. That allows dirt to creep back into the furrow and may affect your seed depth. If we get dirt rolling in, dirt may roll in before the seed falls. So we would want to replace those anytime the bottom edges are worn where they're losing dimension. Something else to look at on your closing frames, if I look at this frame, it has some side-to-side play. That movement is happening in here in the bearing. We should probably, when we're replacing all of these parts anyway, pop that bearing out, put a new one in, so that these closing blades track straight behind the opener and are centered on our seed furrow. The older planters are more prone to that than the newer ones. This tube with the down pressure spring for my closing blades. Has multiple adjustments with a pin adjust in here. This again being the earlier design. There's play that occurs between the pin and the tube, and that's just wear. We pop these pins out, put new ones in. If necessary, we may have to replace the tubes because the holes will elongate over time. This down pressure spring on my closing system, if we're in a no-till situation, there is an optional heavier spring available. Most generally, we can get the down pressure we need simply by moving the spring. There's normally at least, with the new tubes, there's 4 different down pressure settings just with a pin. The firming tire on the back, it's not really a press wheel. It's simply a tire on the back to tamp the dirt down, to push the air out of the soil, create a flat surface. This one's got a little of last year's mud stuck on it yet. It is a Chevron tread tire, the point being that it leaves that pattern on the soil. The idea being, if we do get some heavy rains or we get any crusting after the crop is planted and before it emerges, that we've got a pattern in the soil for cracks to be created, and that tends to hold true. This spring here is also a down pressure spring. There is really no adjustment to it. It's simply a spring to hold some tension on my firming tire. The newer springs have been very reliable. It is a little bit rare that we see a hook broke off. The older planters was a little earlier design and we were more prone to see that. Very simple to check it. Just grab the tire and lift. You should feel that spring catch. If we have a planter with liquid fertilizer on it, which this planter happens to have the liquid fertilizer tube in it, which is a stainless steel pipe coming from the top, this installation is actually correct for this tube, where it comes down in the back of the shoe, out the bottom. It's a good inch above. It's almost an inch and a half above the bottom of the furrow, and it's behind the shoe. The reason we want that liquid to deliver here and not lower is it can interfere with seed placement. Anytime we're delivering liquid in the ground like that, we can get mud balls, and we'd want that above the furrow. We don't. If that were mounted very low, all the way to the bottom, the mud ball that may form on that could actually rake seed down the furrow, and you can see some in-row seed placement errors. You're not asking questions.
Is there anything on the gauge wheels as far as a checkpoint or maintenance point?
Right. So hand me a gauge tire. So when it comes to gauge wheels, we simply want to check the tires, make sure they're not broken, make sure there's no rubber cracks. Again, the later planters have been very reliable. We want to check the bearing, make sure the arm to the wheel is tight and the wheels roll freely. When we rebuild a planter, we put these back on. There are washers on the pins and what we're doing is shimming the gauge tire to the blade. When we install these, push them all the way on as far as they will go, push them all the way in. We'll pick the tire up approximately where it will run in the field, and we can tell that by the depth adjust on the front. It'll catch, and spin the tire. It's acceptable for the tire to touch a blade here and there. It is not acceptable for the tire, when we spin it, to turn the blade. The rubber tire should not act as a brake on the blade itself. It should run very close, but it should not interfere with blade rotation. If, when we do that, we're tight on the blade, the tire won't freewheel, it wants to turn the blade, add a washer underneath.
Is there anything I need to do pre-season to check the depth on the row units, if it's accurate?
So when it comes to zeroing a row unit depth, from one planter to another, and I hope you can see the gauge here, there's simply a metal pin on a numbered gauge. If we were to crank this all the way to the 0 point, all the way back, set the planter down on a concrete floor, and we cranked this back until our gauge tires were snug and did every row exactly the same. What we would do to zero that row unit then would be to simply take the screws loose on this metal gauge and slide it so that the metal pin and 0 lined up, and we would set them all exactly the same. Not all planters in the countryside will run the same gauge setting to get proper depth. It really will depend on the person that zeroed the row unit and how they did it. The main thing there is, once that is done, every row will have the same gauge setting. You would not need to check the depth of the seed in the field for every row if we go across and set all the gauge settings the same. One more thing with row units, this unit being a chain drive, we do want to check our drive chains. This bearing, we want to check that, make sure they turn smoothly. With a hydraulic driven planter like this, we can actually enable that in the display in the cab, set it to do a seed calibration, and then the planter will run stationary off the ground, and that would allow us to check the bearings, check to see if anything is not running smooth, watch our chains run, proper chain alignment. Inside the frame here is our chain tensioners to make sure everything is running nicely and true and correct. So this is the chain drive meter and the drive dog where it engages the sprocket and the metal pins. You will see on this where the pins are worn on the end. With time, that will be normal. If you have a planter where that wear seems to be excessive, or the plastic driver here for the seed plate on the tabs seem to be quite excessive, there is an alignment procedure to that to line that sprocket up with a meter. The 2 bolts that bolt the sprocket assembly to the outer frame, that is slotted holes. We can take that loose and move this sprocket assembly around. And here at the shop, we do have the alignment tools to accomplish that. So this happens to be a hydraulic drive planter. This right here is the orbit motor that drives the seed meters. We've got a speed sensor on the end. They cause almost no problems. We want to just simply look at it, make sure it's secure, make sure it's anchored well, nothing's falling apart. The drive chain off of that motor, if you look at this particular planter, this chain is very loose. This will cause us problems. These chains are important. This planter still has the older mechanical tensioner on this chain. There is a spring-loaded tensioner that is available that is used on the slightly newer planters. But we need to watch our main drive chains so that they don't get loose, because they will begin to skip. Again, from main frame, center frame to wing frame, we've got this drive mechanism, another drive chain, the sprocket driver that will engage with the wing. This assembly drives the center 2 rows on the rear frame, or on the rear center frame. You can check this by hand. You can actually just turn it, feel whether it runs smooth, see whether your chain tracks correctly. Spring-loaded tensioners, again, we want to be free. We don't want any broken springs. It needs to hold the slack out of that chain. If we do need to replace any of the bearings on the drive shafts, we do need to make sure that we put them back in the same place and maintain alignment. When this planner is in field position, the wing frame will engage over the top of this. A similar sprocket with a similar drive dog on it will engage this and drive. We want them running true, we want them running square. While we're doing row unit maintenance, we should be looking at our residue managers, trash whippers. They're called a number of different names. This particular design is a no-till blade, also called a shark tooth. There's several different manufacturers out in the market that are putting these parts on planners, and I think they all probably work very well. Again, they need to rotate freely, and like this one, when I take a hold of that blade, it's got some wobble in it, so we've got some looseness in a bearing. We may need to address that. This is a very simple frame, typical again on somewhat of the older planners. Simple pin adjust, not maybe quite as convenient as some of the newer designs. This is the newer design floating residue manager, floating trash whipper. Being as it is a floating one, we're using a hub on it to control depth. If the hubs engage ground, it'll actually push the frame up, and then frames can float up quite some distance. This particular planner has the clean sweep air cylinders in it, so we can actually control how this rides, how it engages with the ground from the cab. One of the main things we need to look at with this type of frame assembly in a clean sweep cylinder is we do want this pin actually in the bottom hole, so that my maximum down position is caught by the pin and the air cylinder stays free. I do not want the weight of that assembly being caught on the air cylinder. The air cylinders are there to pull, lift, or push down, but the weight of this frame should never clunk down where the cylinder catches it. That should be caught with the pin. Well, here we have a couple of versions of an air compressor on our planners. This one here, being an electric operated compressor, has an air filter on it. Previous owner actually wrote check daily every 10 hours. Helps if I go the right way. Simple little air filter. The electric compressor on this planner is used for the pneumatic down pressure on the row unit. We do want to keep these filters clean. We should really check them daily, because as they're running, this is a dirty environment in the field. And if this filter clogs up, the filter or the air compressor will not be able to get proper airflow, and it will fail because it will not shut down and it'll overheat. The air compressor that you see here is also an electric air compressor. Someone decided that it would be necessary to run two on this particular planner, which is fine. This air compressor also in the box has an air filter in it, and we do need to check that. This particular one is running my clean sweep trash whipper air supply for that. So this particular planner is also a 1250 planner. This one has the Pto pump on it, the 22-gallon Pto pump, which will run one vac fan and the seed drives. We do need to check the coupler on the pump, make sure it is secure on the pump, fastened into the tractor PTO properly. When these run on the PTO on the tractor, ideally they are stable and there's very little quiver or wobble in that pump. If we do see some once in a while that are a little on the violent side, and they will fail. The thing that can do that could be the PTO shaft on the tractor itself, depending on the style that is there, or the coupler here could also be worn. We do want to lubricate this when we install it on the tractor, and in this case where there's 2 bolts through that, we want to tighten those evenly to get the crimp secure on the tractor shaft. They are set to run at 1,000 engine RPM or 1,000 PTO RPM. We normally don't have to have them up that high, but probably 900 plus. This is the oil reservoir then for the PTO pump system. Again, most of these are driving the vac fan and the seed drives. There's also oil supply available there to run the liquid fertilizer pump as well if equipped. When we look at this particular planter, we can see where we've had some oil spillage out of the fill breather cap. In this particular case, that is largely due to the way the hoses are plumbed into the bottom of the tank. The large hose going directly to the pump being to one end, the oil return coming in right below or nearly below the fill cap, the breather. In this situation, if this is happening, what we can do is change these 2 hoses around, these 2 ports, moving my return oil into the tank forward, and the small 3/8 line pulling that to the rear port. They are the same, they're interchangeable, and that is far preferred. I want my main oil flow back into the tank as far away from my suction point as possible. That will help to eliminate cavitation, and it will greatly reduce this oil spillage out of the breather. The oil flow going into this small hose is very low. It's very insignificant as far as the way the flow pattern happens in the tank. Any of our planters may be subject to that. It really depends on who put it together when it was new. Above our tank reservoir here is our oil cooler. That oil cooler has an electric fan on it. That electric fan is then powered by the electrical cord that plugs into the lighting socket on our tractors. It's powered by the center pin. Depending on the tractor that we plug into, some of the older versions, there is no power from the tractor. So if we have a planter that we're putting on a new to you tractor, we may want to check that to make sure that there's power on that center pin of the lighting socket. The fan itself is controlled by a thermostat switch that is installed up here into the cooler. They have been very reliable and cause us very little issues. If we do have fans that don't run, many times it's a harnessing issue or a connection problem. So if we are doing maintenance and we're going to change the oil in the reservoir, we're going to change the hydraulic filter that sits right here. To drain this tank, there's no additional plumbing, no additional hoses in the bottom. It's really up to the individual how we will drain that. I have a tendency to take the large hose off the pump and simply just dump it in a pail. If someone prefers to do something different, we can take this hose off the fitting and let it run out of that port. When the oil is drained, reassemble our hoses, refill the reservoir with hydraulic fluid, install a new filter, fill the tank to the full line on the dipstick, start the tractor and let it idle. Run the PTO briefly, run the pump briefly. If there's any air in the system, it will it will push through the system and back to the tank. So run that PTO at idle for probably 15 seconds, shut it off, come back and check our oil levels. If there's significant cavitation, foaminess in the oil, that will resolve itself with some time. Refill to the full level and start it and let it run again at idle. Once the air is dissipated out of the system, you will have relatively clear fluid in the tank, and you will be near full on the dipstick, and it should be good to run. Typically the cooler fan on the oil cooler as well. We do want to make sure the oil cooler is clean, not full of some sort of field debris. The oil coolers, when we start the PTO pump and engage our fans and we're planting, typically within 15 minutes or so, the oil is heated enough where that fan will run. Typically through the day while we're using it, it'll run non-stop. To go along with the air compressor conversation, again, it depends on how the planter is equipped, but various planters, we will see a black tank like this, which is our air supply. The bottom of those tanks have a simple valve in the bottom. It's always recommended that we dump the air for storage. This valve particularly is actually open. Moisture can accumulate, and it's a good idea to make sure any moisture is released. In recent years, we have begun going to the local parts store, buying inline air dryers and putting them in place. The in-cab pneumatic down pressure system like this planter has on it has a valve block on the side that's a distribution manifold, and then on the back of the planter there's an air control valve. We call it the blue valve. Air filters and dryers can greatly enhance the life of that valve. To talk about bulk fill systems on various planters, pre-season maintenance, it's always good to take the distribution manifold on the bottom of the hopper, open the doors, any debris, old seed that may have clumped up, dirt that may have become hard. We want to open the bottom. We want to clean that out pre-season. Our fan blower does have a significantly large screen on it, but a certain amount of field debris that may be blowing in the air will come through that screen, and it will blow down these big tubes and into our distribution box. Some of these boxes do have some screens and various things in there where it can get caught. So especially pre-season, it's a good idea to open the doors in the bottom of these. There's a couple of different versions out there depending on the age of the planter again. Most of the planters from the 1200 through the 1250 planter will have one that looks like this. The 1255 planters have an updated version. When it comes to setting bulk fill fans when we're planting in the field, a starting point of approximately 3,200 RPM is a good starting point. Diagnostics on bulk fill seed flows is rather simple, actually. If our hoses on our row unit meters, in this case right here, where my bulk fill hose sits on this earlier design meter, they do need to be set together tightly. If you look at this particular planter, this particular row unit, there's an extra piece of tubing in it. That was added a bit later on these planters with this design. Like I might have mentioned earlier, the inside of the tube, if we see hose plugging in this area, the inside of the mini hopper tubes need to be round and smooth. The hoses and couplers need to be fully engaged and installed. But if we have a tendency to plug on our row units in the hose in this area, we need to slow our fan down. If our seed meters run empty and we have no seed flow out here, there's no seed in the hose, the seed is actually back here under the mini hoppers, under the distribution manifold. Maybe it's blocked in the hose over here. Then we need more air, more fan speed. Higher fan speeds will tend to blow too much seed out onto the row unit, and it'll fill up into the hoses. And when that happens, that seed with some pressure on it can actually knot in the hose. So if there's any further questions, comments about what you see here, if some of the things that we've discussed are confusing, feel free to call any of our 3 stores in Laverne, Worthington, or Lake Park. There's someone on staff that would be more than willing to talk to you and answer your questions.